Today I'll be showing you how to create a technical drawing using Fusion 360. The model on the screen is of quite a simple Bluetooth speaker, and this is what we're going to be referencing today. So to begin, what I want to do is go over to the left-hand side of the screen where we see the Design tab. We're going to click on that. And this is where we can take our three-dimensional model and turn it into a 2D orthographic drawing. So we're going to scroll down to Drawing, and it will give us two options when we highlight Drawing. It'll say From Design or From Animation. We want to use From Design. Once we click that, the Create Drawing box will pop up, and it gives us a few options. We want to create a thing called a GA, or a General Arrangement Drawing today, which is, in essence, a 2D instruction manual of how to build an entire product, or how an entire product goes together. So we want full assembly to be clicked in this drop down here. Drawing, Create New, that's fairly standard, should always be the same. Template from scratch, that's absolutely fine. ISO standard, perfect. Units, make sure they're in millimeters. If you are running an American machine or similar, they might appear in inches, but we want to use millimeters in the UK. Sheet size A3 is perfect, really good for printing out and putting into your portfolios. So I'm happy with that, so I'm going to go ahead and click OK. Once I've clicked OK, a new tab opens. This is where we can start to draw in 2 dimensions using the original 3-dimensional model as a reference. So I've got the model kind of floating here with my cursor. That will remain until I click down onto the paper. But I want this to be slightly larger, so I'm going to change the scale from 1 to 5 to 1 to 3. This can always be changed at a later date. I just like to see it quite large on the page as we begin. If I'm finding that the page is getting a bit too busy or confusing, then I will always reduce the size of the drawing. So I'm happy with that at 1 to 3. So now I'm going to click down somewhere in the middle of the page. Everything can be edited after, so it doesn't matter too much where you put your first model. So once that's been dropped there, we're going to go back up to the top left and click on Projected View. Projected View is a great tool. What it does is allow you to pull out different views of the 3-dimensional model, similarly to what we do when working with our 2D orthographic drawings. We look from a left view, a right view, bird's eye view, and a worm's eye view. We can do the same using the Projected View tool. So once it's been selected, you select the front-on view, and you will see, as I move my mouse around or my cursor around, that the view will change depending on where I move to on the page. So here, we'd be looking down on the model. Up here, we'd be looking up at the model. We'd be looking at the left-hand side of the model here, and we're looking at the right-hand side of the model there. Because the left and right-hand views of this model are fairly similar, I'm just going to select one, and that will describe how the product looks from both sides. So I'll probably go for a left view here, but I'll definitely put in a worm's eye view, and I'll also put in a bird's eye view there. And one thing that's really great is just to put kind of 45-degree side angle in so we can fully describe the product. We'll just stick that over there for the time being. Now, in order to move these around the page, you select and drag, and then release once you're happy with where they are, like so. And they will all move in accordance with each other, so they will always stay perfectly in line. Excellent, same over here. There we go. Right, what we want to do now is pull off some dimensions from this product. So what I'm going to do is introduce, in my opinion, the most useful tool in this 2D drawing package. Now that is the dimensioning tool here. You want to select this tool, and what this tool does is it snaps to edges, points, circles or holes in the three-dimensional model, grabs onto them, and it's able to measure between specific lines that you tell it to measure between. So an example of this would be, if I click on the tool there, and I select this corner here, and I select this corner here, and click, you will see, if I zoom in, that has given me a reading of 360 millimeters. Now that's just an example, so I'm going to delete that, and I'm going to show you how to use this tool effectively. When we're creating 2D technical drawings, what we want to do is always go from one point of reference. And there's reason for this. This is so if you hand this technical package on to someone to manufacture the product, you don't want them to get confused. You want them to be able to go to one point of reference, and using that point of reference, be able to read every measurement that they require to build this model from there. So let's use this back line here. And what we're going to do is start by clicking on our datum point or our reference point, and we're going to measure out to the first point that you encounter as you move from left to right along the model. So that would be the underside of the foot of the product. So we're going to click there and drag up. Now that is 50 millimeters away. We can see there. So we know that from the left-hand side of the product to the edge or the left-hand side of the product's foot is 50 millimeters. So that's the first point of reference. We're then going to have another go using that same 0 point there, the datum point, and we're going to go to the right-hand side of the foot, click there, pull up, and click again. And now we know that from one side to the datum point is 50 millimeters, and then from the other side to the datum point is 70 millimeters. And what that tells us is that the width of this foot is 20 millimeters. Now I can check that by clicking like so, and indeed, yes, 20 millimeters. So next, we go back to our reference point. Always go back to the reference point, and we go to the next point of interest, which would be the other foot. And we pull it out, and we click. And we do again for the other side. And we pull out, and we click. And those two are the same. That sounds about right, or looks about right. Now I just want to know how far it is from the datum point right to the end of the product, which is the final point of reference, and that is 360 mil. So we know that this foot is 50 millimeters away from the left-hand edge. We know that this foot is 290 millimeters away from that datum edge, and we know that the entire product is 360 millimeters in length. So what we're going to do now is do the same thing, but side on. And what that will tell us is we know how far back this foot starts, if you look at it from the side, but we need to know the detail of how far in it goes. So we're going to do something similar by choosing this as the reference point here. And we're going to go out to the first point of interest, which is 10 millimeters. Probably better to do it from there to there. So that shows 10 millimeters. So we know that from the front to the start of the foot is 10 mil. And then to the next point of interest is over here. So already, just by taking two measurements from the front as we look at the product, we know that you need to go 10 millimeters in before the foot starts, and then you need to go another 70 millimeters, because 80 minus 10 is 70, to the back. And then from there, we can measure the width of the product, which on this occasion is 90 millimeters. So we're starting to build up a three-dimensional picture of the detail of this product through two-dimensional drawings and really understanding the front and side of the product. Now, what else do we need to know about this product? We need to know things such as the holes where the speaker drivers are inserted into, where are they? And how do we know where to make those holes? Well, same thing again, we choose a point of reference, usually on the left-hand side of the model. And what we need to work out is that center point. Where are we going to drill the holes? So we're going to click on that point of interest, and we're going to drag down. So we know that from the left-hand side of the product to the center hole is 70 millimeters. And we're going to do the same for the other hole. We know now that is 290 millimeters. Same thing again, we need to know how far up those holes are. So we're going to go from the same point of reference to that hole there, but we're going to go to the side. So we can see that it's 55 millimeters from this 0 point here to the center point of that hole there. And they are identical, or mirrored rather. So we want to show that by putting anything called a center line, and we select that edge and that edge. And that shows us that this side here is exactly the same as this side here. They're just mirrored. So that's a good habit to get into, is using the center line tool up here, just to show where things are equal as you look at them. So actually all of these parts here are mirrors of each other, so we just want to put that center line in. Another good thing to do to make it clear for anyone manufacturing these products is show that there's a hole in the face here. We can do that by using center mark. And what a center mark does is it shows that there's a hole there, but it also shows that it's a perfectly circular hole. And we use this tool by clicking on it, clicking on center mark, and clicking on the outside of that incision, and that just shows kind of cross that goes through the middle, showing that it's perfectly circular, and that indicates where to drill. So we've already got a lot of information down, but we could have a bit more. We could have more in the sense of the way that this product's assembled. It seems to me that we made from pine or plywood, something like that, but we need to add more detail. How thick is that ply or pine wood, and how is it joined together? So what I want to do is actually zoom in on this part here, which shows the joint, some mitre joint, and I want to show how this is assembled. So what I'm going to do is go to Detail View up here on the left, click on that tool, and I'm going to select any part of that corner. This is going to be called A. It's kind of like a magnifying glass almost. And I'm going to drop the other part of A there. Probably going to make it 1:1. Kind of like a zoom in. So what we've done is circulate, like so. And then a larger image of A has popped up here. What we can do with this larger image is start to detail it. And what I mean by that is add a thickness. So we can say that is 10 millimeters there. That is 10 millimeters there. And we can also add in an angle using dimensions as well. That'd be angular dimension, sorry. Select that line and select that line, and that shows us that that is 90 degrees. It's probably not necessary on this drawing, as it's perfectly clear that that is 90 degrees. However, if you were using a different angle, something that wasn't quite as clear and obvious, you'd probably want to document that. So that's a good way of showing a piece of detail, is using the detail view, drawing a bubble and pulling it out. Another thing we can do to add manufacture notes, always useful, is by simply writing in text here. So if you click on this icon that has the letter A, this is the text button, and it will allow you to write some manufacture notes. So you can just type in there, pop down. I'm going to say A equals miter joint, 10 millimeters pine. I'm going to highlight that all the materials used are pine for the outer casing. Pine's a great material as it's relatively cheap, it's fast growing wood, and it's easy to work with. I'm also going to highlight that the speaker drivers, so the actual cones or speaker cones, are imported parts. We don't have to worry about the manufacture of them too much, we can just buy them in. There we go. You just add those notes and they will be very helpful for anyone that is going to take this document and use it to manufacture our speaker. Now, it's always good just to have a look over your drawing and observe anything that you've missed, any detail that you might have missed. Now, I've noticed that it's not clear how far this foot comes down, so it'd be great if I could just highlight that. And what I'm going to do is go back to the dimensions tool, click on dimensions, choose another point of reference. In this instance, I will opt for this right point here on the far extreme of the foot, measure up to the first point of interest, just 30 mil up, and then same for the top of the product. So that's 140. I've also noticed that as you look, this side view is a mirror, so I'm going to put a center line in because they mirror each other. There shouldn't be any difference between the left-hand side and the right-hand side. And it's also got me to thinking, perhaps I should put in another note to explain how the foot is joined to the main body of the product. I would say, judging by the simplicity of the design and the fact that it's a product that is designed to be manufactured quite quickly and quite affordably, that it's most likely that this foot is joined using a butt joint and wood glue. So I'm going to put in product foot or product feet joined via butt, joint and wood glue. Simple. Stating the obvious and giving information about how this product is manufactured. The last thing we want to do is come down to this table here, where we can add in detail. One thing that's very important to do is add in the scale. If you remember from the beginning, this is a scale of 1 to 3. Millimeters are assumed, especially in the UK and Europe. There's my name. There's the date that I completed the drawing. Probably don't want the title boxy one. We'll call it Pine Speaker. Drawing number 1. Then we can leave the rest of that to be completed by hand later once the drawing has been double checked by a technician, another teacher, or someone else in the workshop before we get manufacturing this product. So, another look over the product. It's always good to check. As I look at it, I feel confident going forward with making this into a PDF and printing it, and it feels to me like a document that I could take to someone, give to them, and they would then understand the dimensions of the product that I'm trying to describe. So what I'm going to do finally is export this document by clicking the PDF icon up on the top right hand side of the page. I'm going to open the PDF, click OK. Here we go. Document automatically opens for me, and I can then review it one last time before clicking print.